Now that we've been introduced to the data types in Python, it's now time to talk about how to put individual elements of a program together into something a little bit more complicated. And so this requires us talking about control flow, if statements, and loops. As we talk about this, this brings us to one of Python's more unique features, the so-called syntactic whitespace. If you've used a language like JavaScript, C++, or Java, or Lisp, the control blocks are set off by either curly brackets, or rounded parentheses, or things like that. Python does something differently. Instead of using either of those control mechanisms, it uses indentation and whitespace, spaces or tabs. When Python was created, this struck a lot of people as a little odd. The reason that Python does this is that it looks more like the pseudocode that you often see in textbooks, and it forces people to be consistent in how they indent their code. I've come to get used to it, but if you're not used to syntactic whitespace, this often causes problems when you're beginning, because you don't realize when an if statement or a loop ends or not. Eventually your brain will click and you'll be able to follow the indentation very clearly, and it will be obvious where code blocks begin and end. But until you figure this out, this is something to be on the lookout for as a potential problem as you're debugging your code. So let's first begin with if statements. And so if statements begin with the keyword if, followed by a space. And then you have to have a statement that evaluates to a Boolean value. And so this could be something like asking whether a string is in another string. This could be asking whether two integers are equal to each other. All of those evaluate to a Boolean expression, and all of those can be used to create an if statement. Let's pretend for a moment that the middle section of this if statement weren't here. This is called just an if-else statement, and that is a perfectly valid if statement. If the condition creating the if statement evaluates to true, you run this piece of code. Otherwise, you run this code. And in fact, you don't need either of these statements. You could just have a single if statement and nothing else. But often you want to use an if-else statement to cover either case. And in this case, there is no WOLF in the string WOOL, and so when we actually run all of this, it generates this statement here. Okay, but now let's talk a little bit more about this middle section here. The else if statement first evaluates the first if statement, and if that is true, it does this block here. If it is not true, and this evaluates as true, then it runs this block. Otherwise it goes to the very end, and if none of the else ifs were true, it runs this final statement. As I said before, else if statements are completely optional. You probably won't use them very often, but it's a good tool to have around. One thing to be aware of is that you shouldn't be using too many if-else statements. That can lead to overly complicated code. So keep it to a reasonable minimum. 2 or 3 is perfectly okay, but more than that is probably going overboard. Now let's talk about another form of control flow, loops. So while if statements take a Boolean value to create the control flow, for loops take a list. And recall this range operator that we talked about before. And what a for loop does is it takes some variable and assigns that variable to each of the elements inside the list. And so in this case, the list is all of the integers less than 100. And so you have sum that starts off with the value of 0, and as you add to that each of the elements inside this list, the sum keeps getting bigger and bigger. So the first element in this list is 0, so sum becomes 0. The next element is 1, so sum becomes 1. The next element that I gets assigned to is 2, so sum becomes 3, and so on and so forth until you get to 99, and once you add 99, you get 4,950. A for loop is very handy. You don't just have to use the range function, you can use any list that you can think of. You can also use the keys of a dictionary, which is something that we'll be seeing a lot of. If you've used a programming language like Lisp, you may be familiar with what are called list comprehensions. These are very compact ways of writing for loops when you're operating on the list. So, for example, let's say that you want to sum up the first 10 integers. You can just create a very short for loop in this way, and then apply a function like sum, which takes a list and adds up all of the elements together, and then you get an answer. You can also tweak these list comprehensions by adding on filters, like we saw with the list earlier, to the end of the list comprehension. So what this list comprehension is saying is, just like before, we're going to sum up all of the integers less than 10, but we're only going to look at the even ones. And so the way that we write this is that we have a Boolean expression here that takes each of the elements inside the list and divides it modulo 2. So recall, when we do modulo division, we divide by 2 and then look at the remainder. If the remainder is 0, that means the number was even. And so we now have a list implicitly in here that just contains the numbers 0, 2, 4, 6, 8, and we have two things that add up to 10, we add those together and we get 40. If we had instead asked for only the odd numbers by turning the 0 into a 1, we would then get the value 25. Another thing that I wanted to talk about, but I didn't find a really useful place to put it, is string formatting. So oftentimes when I want to print things, I will use string formatting. And so when you use string formatting, you create a string with little placeholders inside the string. And so for example, this says, I'm going to put inside this string another string, followed by an integer, followed by a float. But I only want to see 3 decimal places of the floating point number. So you then use the division operator again. This is not being used for modulo arithmetic anymore, it's being used for string formatting. That's a little bit confusing, but different data types have different operations. So this takes a string and puts it inside the first position. It takes the integer, puts it in the second position, and then puts the float into the final position. You'll get errors if you try to mix and match the data types in here, and this keeps you honest. And so when you evaluate that expression, you now get a nicely formatted string with all of those elements there. There are different ways that you can format these strings. This is a relatively old-fashioned way to do it. I use it because I started learning C++, and this is the format that C++ uses. You do not have to do this, but when you see my code, you'll see me doing this, and I don't want you to be confused. Next up, we're going to be talking about classes. Since Python is an object-oriented language, oftentimes your control flows will live inside various classes. We'll talk about that next, and we'll build a very simple class.